Recall that a general first-order differential equation is looks like this. The left-hand side is the derivative of the unknown function, is y prime, and the right-hand side is some expression that involves the unknown function y and the independent variable t. But of course, it just means that essentially the right-hand side is a function of two variables, t and y, and the domain of the right-hand side might not be the whole plane ty. So there might be some exceptional values where the right-hand side is simply undefined. So for example, here the right-hand side is square root of t squared plus y squared minus 4. Right, so since we have the square root, and whatever expression is inside of the square root must be non-negative. Right, so in our case, t squared plus y squared minus 4 must be non-negative. So which means t squared plus y squared must be bigger than or equal to 4. And I hope you still remember that if t squared plus y squared is exactly 4, which is 2 squared, so then that's the circle of radius 2 on the plane ty. But if it is bigger than 4, it means that it is the exterior of the circle, and hence the domain of the right hand side here is the exterior of the circle of radius 2. So that's what you see here. It means that inside of this circle we don't have the direction field at all, and outside we have our direction field defined by the first component is 1 and the second component is square root of t squared plus y squared minus 4. Alright, now the next example, same thing, but here the right hand side is again some expression in t and y. It happens not to have y at all, but it's alright. So now notice that it contains logarithm, and I hope you know that the argument of logarithm must be positive, strictly positive. So that's why the condition here is that 1.5 minus absolute value of t plus 1 must be positive, or we can rewrite it as absolute value t plus 1 is less than or equal to 1.5, so which means that t plus 1 is less than 1.5 and bigger than minus 1.5. And subtracting 1 we get that minus 2.5 is less than t and is less than 0.5. Right, and that's how we got it. So the domain of the right hand side is given by this inequality. So geometrically it is a vertical, kind of infinite vertical strip. There is no restriction on y, but there is a restriction on t. Alright, one more example. So here we have both the logarithm and the square root. So, and again, whatever is inside the logarithm must be strictly positive. So 2 minus absolute value of t must be strictly positive. So which means t must be strictly between negative 2 and 2. And at the same time, the expression in this square root must be non-negative, so 2 minus absolute value of y must be bigger than or equal to 0, which means that y is between also minus 2 and 2, but now including minus 2 and 2. So in other words, geometrically it's a square, but it's a bit of a strange square. So here, when t is minus 2 and 2, so these parts are not included, but these parts are included. Alright, let me continue with the next example. So that's a question for you. So please invent a continuous function so that its domain is the disjoint union of two disks. So that's a nice little challenge for you. Okay, in the next example, so here the right hand side is t over 3y. There is no logarithm or square root, but there is a division, right? So, and you know that whenever there is a division, then the denominator, of course, must be non-zero. You cannot divide by 0. So here, the only restriction on the domain is that y cannot be 0. So hence the domain is going to be the plane without the line y equals 0. Or geometrically, it's the combination of two open planes. So one of them is y is positive, y is negative. So you can think of this as the union of two half planes. Well, and one more little example is that if you think of the logistic equation, then if you think of this as an abstract equation, if you just don't know that it is a logistic equation, if you just look at, say, as this as an ODE, if I don't tell you that it is supposed to be a population model, then when you look at it, formally speaking, the right-hand side makes sense for any combination of t and y, so which means that its domain is the whole plane R2. But at the same time, if you remember that y is population, then you don't really need to even consider the case when y is negative, so you can simply exclude it from your domain, right? So in other words, if it is an abstract equation and its domain is the whole plane, but if it is an equation that is supposed to model the real process, the population growth, then its domain is the half plane y bigger than or equal to 0.